In algebraic proof, okay, in algebraic proof, you have to memorize the 3 consecutive numbers in many shapes like integers. How we can write as 3 consecutive integers? The first integers maybe is n, the next is n plus 1, the next is n plus 2. Here is as 3 consecutive integers. Okay, we can write 4 consecutive integers. The fourth one would be n plus 3, and so on. Okay, but we will write only 3 numbers. What about if he said even number? We need to write a 3 consecutive even number. It would be 2n. The next is 2n plus 2. The next is 2n plus 4. Here is a 3 consecutive even number also. Okay. What if he said an odd numbers? Odd numbers, so the first one would be 2n minus 1, then 2n plus 1, then 2n plus 3. Here is a 3 consecutive odd numbers. Okay. Maybe if you need 4, the next one would be 2n plus 5, and so on. Each step you add 2. It is a sequence already. What about if he said a square number? Square number would be like n squared. The next would be n plus 1 squared. The next would be n plus 2 squared. Here is a 3 consecutive square numbers. What if he said cube? Okay, by congruency from the square and the cube, it would be n cubed, and n plus 1 cubed, and n plus 2 cubed. Okay. So here is the type of numbers maybe he asked about. Okay, integers, even, odd, squared, cube. Maybe he say a multiple of something. Like multiple of 3. Multiple of 3 would be 3 multiply something, like 3n. It is a multiple of 3. Okay, multiple of 2, 2n, and so on. Okay. Okay. So you need to memorize the shape of type of numbers for at least 3 consecutive numbers, and you can find if you want more. But in Gcse, he doesn't ask about more than 3 numbers, 3 consecutive numbers. Okay. Let's try on number 1. Number 1, he said, prove algebraically that the sum of any 2 consecutive integers is always odd numbers. Okay.
I didn't finish writing.
You need to write? Okay. Okay. Okay, take your time, no problem. If you want, when you are done, let me know. Okay, are we done?
Yeah.
Number 1, prove algebraically that the sum of 2 consecutive integers is always odd number. two consecutive integers. Okay, so maybe it is n and the next one is n plus 1. He said the sum of them. Sum means addition, so we need to add n plus n plus 1. So it would be equal to n plus 1, and 2n plus 1 is the shape of odd number. Okay, we studied that the odd number is 2n minus 1, 2n plus 1, and so on. So here we are done from number 1. Okay, what about 2? 2, he said, prove algebraically that the sum of three consecutive even number is always a multiple of 6. Okay, so we need 3 even. So 2n plus 2n plus 2. We do an addition as he said, the sum. Then the next even is 2n plus 4. Okay, now we can collect the like term. 2n plus 2n is 4n plus 2n is 6n. And 2 plus 4 is 6. So we have 6n plus 6. We need it in the shape of multiple of 6. So we have to take the 6 as common factor. So we have 6 into n plus 1. We can factorize it by common factor. Now we have 6 multiply something. So here is a multiple of 6 for sure. Okay, here is number 1 and 2. If you want to copy, go ahead. If you have a questions, tell me.
When do I minus?
When he say the difference.
Oh, okay. Wait, so the odd numbers is just n and n plus 1?
Hmm?
The odd numbers are just n and n plus 1?
Odd numbers. Odd numbers is 2n plus 1.
So is it just n and n plus 1 and n plus 2?
It is n, not odd number. n plus 1, n plus 2 is integers.
But it says an odd number.
He said the sum of them. That's why we add the two integers to find odd number. Please read the question carefully.
Wait, I'm so confused. Say,
read the question carefully, please.
So I don't use.
Read the question carefully, please. Read. Can you read?
Yeah.
Read it. You can't read it?
Oh, like say it. Prove algebraically that the sum of any two consecutive integers is always an odd number.
The sum of what?
Integers.
Here is two integers. We add them. When we add them, the answer is odd.
Oh, if they said multiple, I use the odd number.
Number 3. Prove that 3n plus 1 squared minus 3n minus 1 squared is always a multiple of 12 for all positive integers. Okay, so we need to work on this form. How? By expanding the brackets and find the difference between them. Okay, so expand the first bracket, it would be 9n squared plus 6n plus 1 minus 9n squared minus 6n and also plus 1. Now 9n squared minus 9n squared, 0. 6n minus negative 6, so we have plus 6, so it would be 12n. And positive 1 minus 1, 0. So here is a multiple of 12, as he said. Okay, so here is number 3. Just expand and collect the like term. Please write it down carefully. Okay, next. He said n is integer. Prove algebraically that the sum of n into n plus 1 and n plus 1 is always a square number. Okay, so we need the sum of them. So n into n plus 1 plus n plus 1. So we had n squared plus n plus n plus 1. So it can be written as n squared plus 2n plus 1. So it can be written by n plus 1 squared. If we expand this bracket, we will get the expansion as n squared plus 2n plus 1. So here is a square number. As he said, the sum of them is always a square number. Yeah, it is n plus 1 squared, which is a square number. So here is number 3 and 4. Please copy them well. If you have a question, please ask. Okay, next we can solve number 7. Prove that the sum of 3 consecutive odd numbers is always a multiple of 3. 3 consecutive odd numbers. Okay, so what is the 3 consecutive odd numbers? So the first odd numbers is 2n minus 1, as we memorize. the next is 2n plus 1. The next is 2n plus 3. Okay, so 2n plus 2n plus 2n is 6n. Negative 1 plus 1 cancelled, plus 3. He needed as a shape of multiple of 3. Multiple of 3 means 3 multiply something. So we can take the 3 as a common factor or factorize it by the common factor, the highest common factor. So we had 2n plus 1 here. Now we have something multiplied by 3. So here is the shape of multiple by 3 or multiple of 3. So here is the proof for number 7. So simple and easy. Okay, so what about number 8? Number 8 proves that the sum of 3 consecutive even numbers is always multiple of 6. 3 consecutive even numbers. Even numbers. What is the even number? We said the even is 2n plus 2n plus 2. Why we adding? As he said, sum plus 2n plus 4. So now we can add the like term. 2n plus 2n plus 2n is 6n plus 2 plus 4 is 6. He needed in the shape of multiple of 6. So take the 6 as common factor or factorized. So we had n plus 1 inside the bracket. Okay, we have 6 multiply something. So it must be multiple of 6. So here is the proof for multiple of 6. So now we can copy number 7 and 8. If you don't understand one of them, please ask. And copy carefully, properly. Shahir, did you understand this topic or not yet?
Yeah.
Okay. What about 13? Here is, he said, a difference. Look, Lamis, difference. Now he asked for the difference. Difference means subtraction. Proves that the difference between the square of 2 consecutive integers is equal to the sum of their integer. Okay. The first statement said the square of any 2 consecutive integers. So what is the 2 consecutive integers? N squared and n plus 1 squared. Okay. He said the difference. Difference means the large minus the small. Okay. So we need to take away n squared from n plus 1. We need to take what? N squared from n plus 1. So we have n plus 1 squared minus n squared. Now we need to expand the bracket. So we had n squared plus 2n plus 1 minus n squared. Okay, cancel n squared with n squared, so the answer is 2n plus 1. Here is the sum of their integers. What is the sum of their integers? N plus n plus 1, which is 2n plus 1. So here is the sum of this integers. So proved. Okay. So when he say difference, so take away the small from the large. Don't forget, take away the small from the large. Okay. Prove algebraically that the sum of squares of any two consecutive even numbers is always 4 more the multiple of 8. Okay, what? Again. The sum of the square of any two consecutive even number. Okay, sum of the square of two even, which is 2n, and 2n plus 2. He said the sum of the square, so we need to square them. And he said sum, so add them. So we had 2n squared plus 2n plus 2 squared is always 4 more the multiple of 8. Okay, so we need to expand and collect the like term here. So we have 4n squared plus 4n squared plus 2 times 2, 4 times 2, 8n plus 4. Okay, now we can collect the like term. 4n squared plus 4n squared is 8n squared plus 8n plus 4. Okay, he said 4 more a multiple of 8. So we need to find a multiple of 8. How we can find a multiple of 8? Factorize by take the 8 common factor. So we had n squared plus n. And we had plus 4. So here is the shape of something 4 more. What is this something? It is a multiple of 8. Okay, 4 more multiple of 8. So we had, here is the multiple of 8. Here is 4 more. So we are done. Proved. Okay, so here is 13 and 14. It's not an easy questions. Okay, but if you understand and memorize the shape of the even, odd, square, cube, integers, you can handle any question. Okay, and don't forget, the sum means add, difference means subtraction between the large and the small, take away the small from the large. Okay, and is means equal. Is means equal. How? He said that the sum of the square of any two consecutive even number, here is the working on the sum, is, which is equal to what? 4 more a multiple of 8. Here is the 4 more multiple of 8. So work, and start with the statement before is. Then you will finish your proof by the statement after is. Okay, so here is how you can handle the algebraic proof. Okay,